Welcome to our series on complex numbers. In this playlist, you'll find many videos on this particular topic which can help you understand the concept and master these strategies. In this video, we'll look into what are complex numbers. Complex numbers are actually expressions, not just numbers. And we'll have algebraic approach as well as graphical approach to understand complex numbers, and then we'll find roots of some equations, some of them which will have complex roots. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. I can also share with you some free related videos. So let us explore what are complex numbers. Well, when we were solving equations like x squared plus 1 equals to 0, we land up as x squared equals to minus 1. Now, this equation was being solved where x belongs to set of real numbers. And in real numbers, if you square a number, you always get a positive number. And therefore, x equals to square root of minus 1 with plus or minus sign, there should be two roots, is not valid, right? So we say for this equation, we have no real solution. However, the equation x squared plus 1 is quite valid. If you sketch a graph of this equation, what do you get? You get a parabola, right? However, this parabola is not crossing the x-axis. It is kind of like this. Since it is not crossing the x-axis, we do not have a real solution. But if we introduce another number which could be a solution, then what? Well, then we do have a solution. So now a number I was introduced, which is square root of minus 1. So this I is what we call a pure imaginary number. And therefore, if I is square root of this, then we have a solution now, and not 1 but 2 plus minus I. So this equation has two solutions, but both are imaginary numbers, which is plus minus I. So you see how the imaginary numbers extended our solution set to the quadratic equations, right? Now let us see how these complex numbers are represented and how we can write them. Normally, a complex number is written with z equals to, let's say, 2 plus 3i, where 2 is the real part and 3i is the imaginary part. And we can actually represent it just as we represent the normal numbers on a plane, and this plane is slightly different. This time on the x-axis we have real numbers and on the y-axis we have imaginary numbers. So 2 plus 3i can be like 1, 2, 3, 4. So that is one unit real, and this is like 1i, 2i, 3i, 4i. And this is I as a complex number. So 2 plus 3i will be 2 and 1, 2, 3. So that number here will be 2 and the imaginary part 3i. Makes sense. Joining from the center, we get a straight line, and that is how we represent the complex number on a plane, right? So this is called Argand diagram. So in this coordinate system, what we have is a real axis and an imaginary axis, and we can represent this number 2 plus 3i. Make sense? Well, in complex number, we do have minus and plus, so a conjugate of this will be written as 2 minus 3i. 2 minus 3i will be minus 3i, means instead of going upwards, we'll go 3 units down. And so that will be represented as this. So this is 2 and minus 3. You get the idea. So we can represent both positive or negative values of real and imaginary numbers as an expression on the Argand diagram. You see that? So that is a basic representation. Now let's look into another concept, and which is we'll now look into the powers of I, right? So we learned that I is basically equal to square root of minus 1. If I square it, in that case I get minus 1, correct? And if I multiply square with another I square times I get minus I, right? And if I take the fourth power, which is minus I times I, right? Or you can say I cube times I, and I cube is minus I, right? So we get minus I times I, and that gives you minus I square, which is minus of minus 1, and which is 1. So you see, as we increase the powers, we do get a set, which is, in a way, if I now do I to the power of 5, I get 1 into I, which is I. So as the powers are increased, we see that the powers of I are kind of like this: 1, 2, 3, 4, fourth power, right? So the values are I to the power of 1 is I square is minus 1, I cube is minus I, and then I to the power of 5 is 1. Correct? I to the power of 5, I to the power of 4 is 1. I to the power of 5 will again be I, and I to the power of 6 will be minus 1. I to the power of 7 will be minus I to the power of 8 will be 1. And this process repeats. So we see a pattern that all the powers multiple of 4 will give you 1. And if the powers are added by 4, you get the same power. Correct? Now, this can also be represented graphically, which I'm going to show you now. So, graphical representation is kind of like this. So, let's have a number 1 here, right, along the real axis, and this is our imaginary axis. So, we have 1, and if I multiply 1 with I, what do I get? 1 times I will be I, correct? So, which is, let's say this, right? So, what has happened is that this arrow, which was in this direction, now is now along the vertical axis, which is the imaginary axis. You see, so if I now multiply I with another I, what happens? I square, and I square is minus 1. I will see that this is equal to this, right? So, this is minus 1, and that is I. So, multiplication by I is rotation counterclockwise. Now, if I multiply minus 1 with again with I get minus I, which is right there, correct? And if I multiply minus I by I get minus I square, which is again 1, and so it goes back. So, as you can see, multiplication by I is clockwise, counterclockwise rotation of the number, complex numbers. This is another very important thing to look at. So I hope you got the visual representation also. And now let's try to see how do we solve a quadratic equation. So let's take up an quadratic equation, which is x square minus 4x plus 5 equals to 0. Now complex numbers are denoted by letter C. So we'll say x belongs to set of complex numbers. Now if I have to find the solution of this, in that case what we can do is we can use quadratic formula, and we can write x equals to 4 plus or minus square root of 4 square, right, which is 16, minus 4ac, so which is 4 times 1 times 5, divided by 2 times a, which is 2 times 1, or this is 4 plus minus square root of 16 minus 20 over 2, right? Which gives you 4 plus minus square root of 4, right? Minus 4 over 2. Now, let me rewrite this as x equals to 4 plus minus. Now, square root of 4 is 2, but minus 1 square root is I. You get the whole idea. So, you could write this as square root of 2, 4 times square root of minus 1, right? Divided by 2. Right. So this is 4 plus minus 2i, because square root of minus 1 is I, divided by 2 gives you 2 plus minus I as the solution of the given equation. So you see, what we get is actually not just a number, it is an expression which has two parts. One is the real part, the other one is the imaginary part, and we get 2 plus and minus I as a solution of the given quadratic equation. So I hope you understand this particular concept. Now let's take up one more example which is kind of important, and which is to find the number I to the power of 99, right? So what is the value of this? We have seen that the powers repeat, correct? So if it is 99, in that case I could write this as equal to I to the power of 96 plus 3. Clear? I to the power of 96 is a multiple of 4, correct? So it is I to the power of 96 times I to the power of 3. Since I to the power of 96 is a multiple of 4, that will be just 1, and I cube, as you know, is minus I, right? And therefore, we get minus I as the answer of this particular question. So if we have a pure imaginary number, we can always evaluate its power very easily. You hope, right? So I hope with this you have learned few concepts. Explore our playlist to know more about complex numbers, master the strategies. I'm Anil Kumar. You can always watch my playlist and master these strategies. Thanks for your time and all the best.